G'day folks, I'm going to have a look at question 5 from exercise 2J. It's more exponential equations. We're going to see how the method I showed in the last video basically works for even this kind of question. So question 2J chucks in a couple of trickier or harder looking ones, and it even starts with some unfamiliar looking questions, right? So let me start. I'll do part A, part C and part F, and that should cover pretty much all the different types that we have there, right? So A, C and F in question 2J. So part A starts with 7 to the power of x. Let me change colours, sorry folks. Seven to the power of x equals 1 over 49. Now remember, in the last video when I showed the definition of a logarithm, I defined it like this. I said if a equals b to the power of c, well then log base b of a equals c. Now I was taught this when I was in year 10, right? Way back in the 80s. I was at Belmore Boys High School. I had a ridiculously tall teacher, Mr. Smith, and big afro, right? It was the 80s and he didn't lose the 70s afro. I mean big afro, like it was as wide as his shoulders, literally. Really tall, really long pointy fingers. And even if we sat at the back of the room, he would ask questions by leaning over and pointing at you, and he felt like he was just like this, you know? It felt like he was really getting his finger in your face. And I remember him standing at the front of the room explaining how to think about this thing. And it stuck. So I'm going to do the same for you guys, okay? So what he said was, imagine you come along and you grab the A and you sort of brace yourself on it, and then you hang on to the B and you pull the B down underneath, right? So here's the A, it's still there because it was anchored in place. The B I pulled down underneath, and then the C fell down out of the sky and landed there on the right hand side of the equation. And it can go both ways, right? So I can pull the B down, or over here I can grab the A and push the B back up. So I can do it both ways, right? And he did it with a sound effect. He was like, and the sound sort of stayed with me. And I still think when I see these exponential equations. Mr. Smith's explanation so stuck with me that when I see equations written this way, look, over here the exponential is on the right hand side, right? Over here the exponential is on the left hand side. That even when I see equations written this way, because of what Mr. Smith said and did, I rewrite the equations around the other way, right? So I'm going to change this equation around so that the exponential is on the right hand side. So here I go. So all I did was just rewrite the equation the other way around. That's all I've done. Right? 7 to the power of x is exactly the same as 1 over 49. It's exactly the same thing as saying 1 over 49 is exactly the same as 7 to the power of x. Okay. Now I can do the little log transformation, if you like. Transformation is not technically the exact right word, but let's just go with it for now. So I'm going to hang on to the 1 on 49. That's just a number. I'm going to hang on to it. I'm going to grab the 7. I'm going to pull it under. So I get log base 7 of 1 over 49 equals x. Right. Now, guys, this would work regardless. I don't care what number is here. It can be a whole number, a fraction, it doesn't matter. Any number that's there on the left-hand side, it's got to be a positive number, but we'll get into, you'll get into why that's the case later on when you study logs in year 11 and 12 in the advanced course. But just as long as it's a positive, any kind of positive number there, it doesn't matter. Okay, it does not matter to me. As long as this is a positive number, equals any number here to the power of any exponent with a pronumeral in it. I don't care. Number, exponent, this is exactly what you do. Okay? And then you end up with log base 7 of 1 over 49 equals x. The next thing I showed in the last video, was the change of base law. And the change of base law said that if I've got log base B of A, I can change to any base I want, right? So I can say that that's log base anything I want, n, log of A base n over log of B base n. Okay, and then I can use that because your calculator only does base 10. Well, it does one other base, but let's, we don't have to worry about that until we do. But it only does 2 bases, and 7 is not one of them, right? So either of the 2 bases that are built into your calculator, 7 is not one of them. So you need this change of base law to be able to work out what this thing here is. Okay, so let's do that. So x is going to be, I'm going to change the base to base 10, log base 10 of 1 over 49 divided by log base 10 of 7. And then I just stick that into my calculator. So I'll do that. I'll just get my calculator out of my bag. Should have prepared that earlier. Give me a moment. Now, I'm going to show you something kind of funky. My calculator, you can actually, the calculator I use now, you guys are not actually allowed to use in the HSC. So you can't, but I'll just sort of bring it up on screen. If it'll focus, please focus. Come on, focus. Anyway, that's the one there, right? So this calculator here, you can actually put in any base for your log. Now I'm probably screaming into the microphone there, I should move further back. You can put in any number you like for the base there. But I'm going to use base 10. I'm not going to use base 10. I'm going to do exactly this thing here. So we've got a fraction where on top we've got log base 10 of 1 on 49. And on the bottom we've got log base 10 of 7. Okay, so I've just entered, as you can see there. And we press equals. And our answer is -2. So x here is -2. That's it, job done. Okay? It doesn't matter. It doesn't matter. I don't care what number is here. I don't care what number is there. This technique is exactly what you would have done for questions 1, 2, 3, and 4 before now. Right? Let's move on. We'll do part C. We're going to see that part C is exactly the same as this, right? So part C, 11 to the power of x equals 1 over 121. 11 to the power of x is 1 over 121. So I'm going to do exactly what I did last time. I'm going to reverse it. So I've got the exponential expression on the right hand side. So 1 over 121 is 11 to the power of x. Right? So log base 11 of 1 over 121 equals x. So then I get my calculator. I do a change of base law rather. So change of base law, log base 10 of 1 over 121 over log base 10 of 11. Okay, go to your calculator. And again, x is -2. Okay. Let's go to part F. Part F, that looks a bit different, right? You've got a negative power. So what's going to be different there? Well, let's have a look at part F. And we're going to basically follow exactly the same technique, right? So here we go. So part F says we've got 5 to the power of -x is equal to 1 over 125. Okay, I'm going to write it around the other way so the exponential part is on the right hand side. So log base 5 1 over 125 equals negative x. Right, the power just sort of falls down. You can do the change of base law over here. So this tells me that negative x is equal to negative 3. Well, if negative x is negative 3, well then positive x is positive 3. And that's it, job done. And they all work out exactly the same way, guys. Just follow the technique, follow the method I showed you in the video, and you can't go wrong. Okay. I hope that helps. There's going to be a little exit quiz on the way out now. Please drop an answer to that, just so that I know that you've watched this and you've interacted with it. And when we're all back in class together, we can all say together when we're solving exponential equations. Thanks, guys.